Hello everyone, today we're going to talk about assignment 3, and the first thing we need to do is to import necessary libraries like request for getting requests in the URL and beautiful soup for parsing and pandas and numpy for your basic data collection analysis. And we need matplotlib to plot necessary graphs, box plots, and etc. So the first thing we did is to get the URL and get the response from the URL. As you can see, it's positive here, 200, okay. And we need to then parse that into beautiful soup to get the HTML code. And then we see that we have to find H3. So this is the website that we're working with, and in the title of this, like the link that we need to get into so that we can have the 22 available in stock value, we see that it falls under the H3 tag. So we are essentially getting H3 and the first link in that H3 tag. And then we are basically writing like title is under the tag of H1 and price is under the tag of P, price color, and in stock availability is under the P class with the class of in stock availability. And this is for like the only one page. So we are just testing it to see if everything is already working. And it seems like it is. So now we see that we have 50 pages. So we have to go from 1 to 51. So it's exclusive. And then we see that how the pages are changing. So we see this is kind of this variable is changing in here. So we are basically writing like this page as the range in 1 to 51. And we are essentially just copying and pasting this code to here so that we are doing every page and saving it to our data array. And then we are doing it and we are saving it to the data frame. And essentially we are giving title, price, and availability. And I am saving it to CSV to not just run the operations again, so because it just takes some time. So from then on, I'm working with the CSV. And as you can see here, I have the index here. So when I saved it to the CSV file, it just saved with the index. So I dropped it, the first thing I did. And the first couple of things that we need to do is to, as you can see here, we have price with the currency. So we need to delete this currency, like replace it with nothing. And we are changing this object to float and then multiplying it by 125 so that it becomes USD. And we also have availability in stock, which is not good for us. So we are essentially extracting only the digit in here. So like we have D here that is extracting it. And now we are also making it integer so that we have integer and float. And we also need to do price per stock. So we have to divide the whole column of price USD to stock count. So it works pretty fine. And we also need to create another column book credits so that if there is a row in stock count that is bigger than the median of that column, then the price is multiplied by 0.85, or else it just stays the same. So like obviously this one is really big, so it would be bigger than the median. So now as you can see it's changing, but like the smaller numbers like here, they are not changing, they're staying the same. And we also need to do data normalization like stock z-score, price min-max. We are essentially writing subtract the current cell from the mean and divide it by standard deviation. And then for min-max, we are doing current cell minus mean value of this, and then dividing it by max and mean subtraction. So as you can see here, this is the original stock count here, and now it becomes z-score, and etc. And we also need to do some binning. So we have price USD. So it would be logical to do low, medium, high. So we are dividing price USD from min to max to 3 types, like low, medium, high. And we are cutting our data frame so that it would have another separate price category, and that will have assigned based on price to low, medium, or high. So now we're just plotting it, and here as you can see they are pretty evenly out. And for encoding, I am getting dummies from price category, and I am writing like how many of them are price low. So as you can see here, like we have this number of price low, and they are not, and this one is not, and the rest are high and medium. And as you can see, df.describe is just doing all the necessary descriptive findings like count, mean, std, mean for every numeric columns. And also what we could do is we are grouping the df. We are grouping the df, and we are writing like values price USD. Like this would be our column. and index price category would be our like index that is not duplicated, and we are just getting the mean. And here is the result. Like for low we have this number, for medium this number, and for high this number. And we can also box plot the price USD to see the outliers, the IQR, and etc. So, and also we can see the relationship between book price and stock count. Like this is called scatter plot, and basically we are getting like how many, the deeper the color is, how many of them are there. Like for example, like how many are appearing on this particular part of the graph. So what you may wonder is, what is this red line? This red line is basically showing the regression, like the correlation between price and stock count. And as you can see, there is no really that many, there is like almost close to zero correlation, as you can see. So we can also verify this by Pearson. So we have stock count and price USD, and we are calculating this with this library that we have imported here. And as you can see, it is really close to zero. So this number, and we can also verify like if they are statistically significant to each other by p-value. So we have p-value, and we are like giving it this value to like compare to. We can also use like 1 or like 0.05. So, but the most statistic analysis use 0.05. And we are comparing this, and we are getting, since p-value is bigger than this value, we failed to reject null hypothesis, and there is no statistical significant correlation between price USD and stock count, which is obvious from here. And we can also see the correlation between each column, like with heat map. So we can say like with method Pearson, we are writing correlation, and we are printing that correlation with heat map. So here, like this is the correlation in the visualization, but here is the result. And as you can see, like price per stock and stock count have some kind of correlation, like negative correlation of 0.64, but it also like gets into question, like because price per stock is also like calculated by stock count, so it would have some correlation in there. And as for stock count and price USD, there is no like really good correlation in there, and the only correlation is the one that price per stock is like being dependent on price USD and stock count, so obviously it would have some correlation to those variables, and which is not really like which is really coincidental and not like would be considered like a finding of a new correlation, because it's dependent on those variables. That's all.